Okay, so now we are talking about characterizing schedules based on recoverability. Okay, so when we are talking about transaction processing, there are two major topics that we discuss. One is concurrent execution of transactions, concurrency control, when multiple transactions execute at the same time in interleaved fashion, and the other is recoverability from failures. So here, what we are trying to say is we are trying to characterize schedules based on, or we are trying to find the characteristics or describe the characteristics of schedules which can be recovered from failures, which can recover from failures. That is what we are trying to describe. Now, first of all, what is a schedule? Schedule is basically an order of execution of operations within the transactions. So we said multiple transactions execute in a system at the same time. Each of these transactions will have multiple read, write, etc. operations within them, and there are different orders in which these operations within transactions can execute on a system. And a schedule is actually an order, a single order in which all these operations within the transactions execute. That is a schedule. Okay. So when transactions are executing concurrently in an interleaved fashion, the order of execution of operations from all the transactions is known as a schedule or history. Okay. So a schedule S of n transactions T1, T2, etc. Tn is an ordering of the operations of the transactions. So, like we said, second. Okay. So we said T1 is a transaction which contains a first a read on item X, and then you have a write on item X, and so on. Similarly, T2 also will have several reads and writes on items X, Y, Z, and so on. Okay. So what is the a schedule? A single schedule as a single ordering of these operations within the transaction. Okay, so first, in the case of a schedule, we might have first is a read on X, and then you might have a write on second transaction might do a write on Y, and so on. So the sequence of operations is known as a schedule. But one thing which is very important is operations from different transactions are interleaved the schedule S. However, for each transaction Ti that appears in the schedule S, the operations of Ti in S must appear in the same order in which they occur in Ti. That is, we are saying T1 has a read that followed by a write. That ordering within the transaction should not be changed. That is, we cannot, in the schedule, we cannot have a write first in transaction T1 followed by a read, right? Okay. So that is what a schedule is. So basically, a schedule is an order in which the operations within a transaction are executing. The only condition we state here is that if there is a particular order of operations within transaction Ti, that ordering has to be maintained. So you cannot mix up the order which is already given in transaction Ti. That is the only condition which is there. Now, for recovery and concurrency control, the main operations which we will be focusing are read item and write item, and maybe also the commit and abort operations. So, a shorthand notation for describing a schedule uses the symbol B for begin transaction, R for read item, W for write item, E is for an end transaction, and finally commit and abort. So, these are the main operations which will be involved, and based on this we will look at how a transaction can be described. Not a transaction, a schedule can be described. Okay, so here we have two transactions T1 and T2. Okay, the operations in T1 are these and operations in T2 are these. Okay, now when we talk about a schedule, we can interleave these operations like this. That is, if you look at this in the timeline, first a read on X happens in transaction T1. So that is why the notation is read X in transaction 1. and the next operation is read item in T2. Okay, so read item X in the transaction. The next operation which happens is a write item in transaction T1. So it's a write operation in transaction 1 and the item written is X. Then you have a read. So you have a read in transaction 1 and the read item is Y. So after that, if you look at the timeline, the next operation is write on X in transaction T2 and finally you have write on Y in transaction T1. Okay, so the same set of transactions, T1 and T2, the operations can be in a different order also. So this is another schedule with respect to the transactions T1 and T2, where you have a read on item X first and then a write on item X in transaction T1. So you have R1 of X, read on in transaction X, read in transaction 1 on X, then you have got a write. Similarly, after that, it is read on X in transaction T2 and write. So R2 of X and W2 of X. And finally, it ends with read on Y, right? So maybe at the end, you can have a commit or abort depending on what sort of, whether it is a success or a failure, whether there is an error or not, and so on. So we have schedule A, it has a single an order like this, right? You have an order like this and it is same transactions T1 and T2. Here you have a different order, same transactions, right? Okay, so this is what a schedule means. Next we are going to look at what do you mean by conflicting operations in a schedule. So two operations in a schedule are said to conflict if they satisfy the three conditions, that is, they belong to different transactions, they are trying to access the same data item X, and at least one of the operations is a write item. That is when we have conflict, right? But if both are read, there is no conflict. But if one of them is a write, you have a conflict. So two operations in a schedule are said to conflict if they belong to two different transactions, if they access the same data item X, and at least one of the operations is a write, then you say that the two operations are set to conflict. So if you look at schedule A, okay, if you look at schedule A, okay, you have a read on X here and you have a write on X in another transaction. So these two operations we can say are these two operations are conflicting because they belong to two different transactions. They are accessing the same data item X and one of them is a write. That is when we say that the two operations are said to be conflicting. Okay, we can say R1 of X and R2 of X do not conflict because both of them are read. Now W2 of X and W1 of Y do not conflict because they're trying to access different data items. And R1 of X and W1 of X also do not conflict because they belong to the same transactions. Intuitively speaking, two operations are conflicting if changing their order can result in a different outcome, right? Changing their order can result in a different outcome. So that is when we say that the two operations are conflicting. Next, we have the concept of a complete schedule. These are terminologies which we want to get familiar with. Okay, a schedule S of n transactions, say T1, T2, etc., Tn, is said to be complete schedule if the operations in S are exactly those operations in T1, T2, etc., Tn, including the commit and abort operations is the last operation. And for any pair of operations from the same transactions, their relative order of appearance is the same. Okay, so the first of all, the operations are exactly those operations in T1, T2, etc., Tn, and the order in which the operations appear for a transaction Ti is the same as it was previously mentioned. Okay, in whatever it is there in Pi itself, And for the third condition, these two we have already come across earlier also. And for third condition, for any two conflicting operations, one of the two must occur before the other in the schedule. This there should be total order. There should not be any partial ordering of operations. So there should be a clarity of which of these operations occurs first when we talk about two transactions. So that is when we say that a schedule is complete. Now, but in real transaction processing systems, it is difficult to encounter complete schedules in a transaction because when we talk about a transaction processing system, the transactions get submitted to the system in a continuous fashion, and the operations are also executed in a continuous fashion. So new transactions are continuously being submitted to the system. So we cannot say this that a particular set of operations is a complete schedule because the operations are getting added continuously onto the system. So it is useful to define the concept of a committed projection of a schedule. Projection of a schedule, which include only the operations in the schedule that belong to a committed transaction. Operations in a schedule that belongs to the committed transactions is called a committed projection of a schedule. Okay, we are talking about a projection of a schedule because we know that we cannot talk about either the transactions get committed submitted to the system continuously. T1 is being executed, and in the meantime say another set of T2, T3 and they get submitted to the system. Okay. അപ്പോൾ എപ്പോഴാണ് ഒരെണ്ണം സ്റ്റാർട്ട് ചെയ്യുന്നത് എപ്പോഴാണ് ഒരെണ്ണം സ്റ്റോപ്പ് ചെയ്യുന്നത് അങ്ങനെ നമുക്ക് സ്പെസിഫിക് ആയിട്ട് പറയാൻ പറ്റില്ല. Gets continuously being updated to the system. So we can only talk about projections of schedules. Okay, projection means it's a part of this only we can talk about. So we are talking here, we are talking about a committed projection of a schedule S, which is a projection or a part of the schedule, which includes only the operations in S that belong to committed transactions. Okay. Okay, so we have seen what a schedule is, right? So next we will try to describe schedules which are easily recoverable. So we'll look at some of the definitions and characteristics. Okay, so for some schedules, it is easy to recover from system failures, whereas for others, the recovery process can be quite involved. And so it is important. So basically, what we are trying to do is to characterize the type of schedules for which recovery is possible in a relatively easy manner. So these characterizations, that is when we say we are trying to characterize the schedules or characterize recoverable schedules, we are not actually talking about recovery algorithms. Okay, how to recover based on an algorithm. That is not what we are trying to say. We are just describing the theoretically the characteristics of schedules which are recoverable from failure. Okay. Okay. So first of all, one important property which has to be there in schedules is that once a transaction T is committed, it should never be necessary to roll back that particular transaction. Okay. So let us say we have got say schedules like this. Say let us say we have transactions T1 where it is say reading some variable X. Okay, and it is doing some operation, so x is equal to x minus 100, right? And then it is writing this. Okay, let us say this is transaction 1, and we have maybe another transaction T2 which is executing, which will after this is the timeline, this is the direction of the timeline. So we have these steps which are executed, and let us say we have transaction 2, which again reads the variable or the value x, and it will do an update x is equal to say in transaction T2, let us say x is equal to some x plus 200, and then you are doing a write w2 of x. Okay. So in this, let us say the execution happens in this particular order. So we can see that first transaction T1 read x, made some modification and wrote this value onto the variable. And when transaction T2 reads this, it is basically what is written by the first transaction that is being read here, and the processing is being done. Okay. Now let us say this transaction does a commit here. Okay, it commits. It has finished its operations and it commits. So whatever operation, whatever calculations are done here are committed onto disk. It is written onto disk. Okay, that is what commit means. Now let us say this transaction after several operations realizes there is some error, and let us say it aborts. Okay, so what is the problem here? So it aborts means whatever operation has is done here will be undone. Okay, you're moving back to a previous state. So which means whatever data is read by this transaction in variable x is no longer correct. Which means this transaction will also have to be aborted or rolled back. But here what we see is a committed transaction has to be rolled back, which means whatever is written on disk has to be rolled back, which is a big problem. Okay, so uh, when we execute transactions, it is important that committed transactions should never be rolled back because the cost involved is much more. So when when a committed transaction is not rolled back, it ensures that the durability property of transaction is not violated. Durability means once you write something onto disk, it is durable. It should never be undone. Okay, so schedules that theoretically meet this criterion are called recoverable schedules. So this particular schedule or this particular order of execution where we have transaction T1 executing these set of operations followed by transaction T2 executing this schedule is not recoverable because committed transaction is being rolled back. So that is what we call non-recoverable schedules. Okay. So recoverable schedule means that it is a schedule in which no committed transaction should be rolled back. That is recoverable schedule. And schedule where a committed transaction may have to be rolled back during recovery is called non-recoverable schedule, and it should not be permitted by a database management system. Okay. Now, what is a condition for a recoverable schedule? Condition for a recoverable schedule is a schedule is S is recoverable if no transaction T in S commits until all transaction T dash that has written some item X that T reads have committed. Okay, so schedule S is recoverable if no transaction T in the schedule S commits until all the transactions that have written some item X that T reads have committed. Okay, so basically what it means is if this schedule has to be recoverable, what has to be done is that is all the transactions which have written the item X. Okay, T2 is reading item X. So all the transactions which have written this item X have to commit. Okay, ഇത് കമ്മിറ്റ് ചെയ്തിട്ടേ ഈ ട്രാൻസാക്ഷൻ T2 കമ്മിറ്റ് ചെയ്യാൻ പാടുള്ളൂ. That is what it is saying. Okay. So when a transaction T commits, all the transactions that have written an item that this transaction reads, okay, all those transactions have to commit before this transaction has to commit. So I'll go through this once again. So the condition for a recoverable schedule is that a schedule S is recoverable if no transaction T in S commits until all the transactions T dash that have written some item X that T reads have committed. ഈ റീഡ് ചെയ്യുന്ന ഐറ്റം റൈറ്റ് ചെയ്ത എല്ലാ ട്രാൻസാക്ഷൻസും കമ്മിറ്റ് ചെയ്തതിന് ശേഷം മാത്രം കമ്മിറ്റ് ചെയ്യാൻ പാടുള്ളൂ. അങ്ങനെ ഒരു ഓർഡർ ഓഫ് എക്സിക്യൂഷൻ ആണെങ്കിൽ then you can say that the schedule is recoverable. Okay. Okay, so now we'll look at examples of recoverable and non-recoverable schedules. So we'll start with this schedule first. So in this schedule, if we look at this, first initially transaction 1 is reading X and is writing X also. And transaction 2 reads the same data item here, which is written by transaction 1, right? So if the schedule given has to be recoverable, then what we said is this transaction T2, since it is reading from transaction T1, it can commit only after T1 commits. Okay, it can commit only after T1 commits, right? So, but here if you look at this, transaction T2 is committing first. So, which means this is not a recoverable schedule. Okay, that is here. We have transaction T1 which is reading and writing X, and transaction T2 is reading the item written by T1. And in the definition for recoverable schedule, what we said is if we have such a transaction which reads an item which is written by another transaction, that transaction too can only commit after the transactions which wrote item X have committed. Okay, but here we see that before 1 is committed, we have commit for 2, so this is not recoverable. Okay, now let us look at this particular schedule. So again, here we are looking at reading of X. Okay, here there is a write. Okay, write of X. Now, if after this write, if you have a transaction or the second transaction, the writing is done by transaction 1. Now, if T2 reads this X after this point, then we have the restriction on the commit. But we do not have a read of X by T2 at this point. So the order of commit is not really important. So you can say this is okay, this is a recoverable schedule. Now, what about this? Okay, X is being read by 1 and it is written by 1. Okay, so here we have transaction T2 reading X after it has been written by T1. So for this schedule to be recoverable, uh, T2 can commit only after T1 commits. So if you look at this, T2 commits only after T1 commits. So this is recoverable. Okay, what about this? Again, similarly, R1 transaction 1 reads X, it writes X, and 2 reads X, so it can commit only after 1 commits, right? So there are no commits here, there are only aborts. So 1 gets aborted, so naturally 2 also has to be aborted, right? Because it reads from 1. So this is okay since there are no commits here. So basically, this is the only schedule which is non-recoverable. Okay. Now, moving on to other types of characterization of schedules. So the one we saw is called recoverable and non-recoverable. That is the characterization we saw here. Now, next type is there is a phenomenon known as cascading rollback. Okay, this is an example. Okay, if you look at this schedule, we have this item X is being read by transaction 1, it is being written, and whatever is written by transaction 1 is read by transaction 2, and some other operations are also being done here. And we see that first transaction gets aborted. First transaction gets aborted, which means whatever is written by transaction 1 here is no longer valid. So 2 also has to be aborted. Okay. So which means because 1 is aborted, 2 has to be aborted. Now, if there is another transaction which read from 2, then that also has to be aborted. So you have got a cascade of aborts or cascade of rollback. So this is called cascading rollback. And cascading rollback is actually a very expensive operation because um, it involves a lot of undo operations. Okay, so it is not actually a feasible way of executing transactions. That is not a feasible type of schedule. Okay. Uh, okay. So about cascading rollback, it occurs in some recoverable schedules. It occurs in some recoverable schedules where an uncommitted transaction has to be rolled back because it reads an item from a transaction that has failed. So we saw this is the example which we talked about also. Okay. Now, because cascading rollback can be time consuming, time and resource consuming, it is important to characterize the schedules where this phenomenon is guaranteed not to occur. So this, since it is time and resource consuming, we do not want such sort of schedules like where there are cascading rollbacks. So we want to characterize the schedules where this particular phenomenon of cascading rollback is guaranteed not to occur. Okay, so such a schedule is said to be cascadeless. So schedule is said to be cascadeless if every transaction in the schedule reads only items that were written by committed transactions. Okay, so if we had a commit here, that is this transaction T1 read X, did some manipulations and wrote this back. Now, if we had a commit operation here, which means if we had a commit here, then it was okay for the second transaction to read this item and process it. Okay, then you would not have a cascading rollback because since it is already committed, there is no what if at all there were any errors, the commit would not have taken place, and this transaction T2 would not have read from it. Okay, so if there was a commit here reading the data X by transaction T2 was okay, and there would not be a cascading rule. So a schedule is said to be cascadeless if every transaction in the schedule reads only items that were written by committed transactions. Committed transactions in a read ആണെങ്കിൽ there wouldn't be any cascading rollbacks. Okay. So to satisfy this criterion, okay, R2X command in schedule SD and SE must be postponed until T1 is committed. Okay, that is what we said. Cascading rollback can be avoided if all transactions read a particular data item only after the transactions that have written the particular data item X has committed. Commit ചെയ്തതിന് ശേഷം മാത്രം നമ്മൾ ആ data item read ചെയ്യുന്നുള്ളൂ. Okay. Okay, now we move on to a third type, which is a more restrictive type of schedule, more restrictive than cascadeless schedule, which is called a strict schedule. Okay. Strict schedule is where transactions can neither read nor write an item X until the last transaction that wrote X is committed. Strict schedule എന്ന് പറഞ്ഞാൽ you can a transaction can both read and write a particular data item only after the transaction which is written that item earlier has committed. The cascadeless what we said is that is in order for a schedule to be cascadeless, a transaction can read a data item only if the transaction which already wrote it has committed. Here in this case we are saying it can read and write a transact or an item X only until the last item that wrote X is committed. Okay, so it is more restrictive than cascadeless. So all strict schedules are cascadeless, and all cascadeless schedules are recoverable. So in the case when we are designing recovery protocols, okay, we only allow, or the database management systems only allow strict schedules. So in that case, recovery becomes a lot more easier.